Oh, g'day champions. We're back with the last part in the 3-part series on this twin reverb. Check the description below. I'll put the links for the first 2 videos to bring you up to speed. Go back, watch them, come back, watch this. These amplifiers are classics for a reason. The AB763 circuit that you find in these and various other Fender amps like the Super and the Deluxe Reverb, they're only as complex as they need to be. They're very graceful circuits. Every single component has a purpose, and it's only just as complex as it needs to be. Obviously, you're not playing every single style of music through this without pedals or something in the front end, but there's nothing quite like standing in the same room as a big wide open twin. Speaking of twins, nice of you to join us. Where you been? I was at the post office. The post office. It's hard to find good help these days, champions. Whoa, hang on. I didn't ask to be cloned, right? First you hide me out in the storeroom so customers don't see me, and then you bloody make me wear the same clothes. I've got to pretend to like Mastodon. Then you make me grow this stupid looking beard just so I look like you. And when are we going to talk about the penalty rates, huh? Yeah, righto. We'll talk about it later. Oh, later. We'll talk about it later. It's always later. We'll go to the brewery later and we'll talk about it there. Well, yeah, thought that's fair. Righto. Alright champions, we've got the new sockets in there. I had to enlarge the holes a little bit because, well, Belton's a slightly larger diameter if they're seated well against the chassis and not just sitting on that shoulder there. So we're going to redo the heater wiring for that. I removed the rest of the heater wiring because it was half of them were burnt and then the wire was really stiff and I need to get to the sockets and it was in the way. Then I removed all the wiring that had the green shit on it, and this is literally all that's left, so I think I'll just go the whole hog and replace it all, And we're in this far. It's by the time you get to this point in an amp, it's kind of a full rebuild, which sucks a bit, but at least we know it's going to be solid from now on. And here's new boards populated, clean and populated, all new bypass caps. I wanted to use some carbon comps there to play with the phase inverter plate load sort of intentional distortion, but the only ones I had in stock were a 1/4 watt, and I don't trust them in that position, and the only other ones I had were heavily out of spec. So someone commented on the previous, I think it was part 1 video, about is there any advantage to using carbon composition. In some places there is. You can use them for a subtle addition of distortion. They tend to, when they're under high voltage, they do distort the signal somewhat. They become non-linear. It's a taste thing, is what I'm saying. But the biggest issue with them is the inconsistency, the fact that there is no real reliable source of them anymore, and when you do buy them, they're often heavily out of spec. I got some recently from CE Distribution, and they were like 15% out of spec when they're brand new in the bag. They're affected more by temperature and humidity, so there's just a bit of a gamble when you're using them in some positions. For historical stuff, yeah, sure, but this ain't a historical amp, particularly with what was done to it. And some people say the metal film is cold sounding. I think that's primarily psychological. There is a difference, but the sort of middle ground is carbon film. So we've gone with half-watt carbon film for pretty much everything other than where I wanted to keep the noise level lower, and anywhere in the power supply. We've gone with either wire wound or metal film there as well. So it's time to start rewiring the valve sockets after we've cleaned up the preamp ones anyway, and get all that slime off, give them a good wash with solvent, clean up the solder, and clear the eyelets ready for the new wiring. Then we'll start working on the front end with all the pots. There's still some green ooze there to be taken care of. Alright, here we go champions. No smoke or flames, that's always a good thing. Peaked at around 100 watts there. It's dropping down to about 57 watts there in standby. Alright, we'll take it out of standby. Ooh. Little hum pulse there, which I might look into. Just stabilising. No smoke still. So I've got it biased to about 50%. We're pulling about 129 watts from the wall, as accurate as this shitty meter is anyway. It's just indicative. We've got about 2.4 volts drop across the primaries of the output transformer and sitting at about 450 on the plates. So I've got the reverb tank plugged in. There's a little bit of hum when the master's down, so I think that's probably not optimal grounding. I'll look at, that's actually grounded to the tail of the phase inverter as opposed to an actual ground. So I'll look into that. That's the original circuit. the original silver face circuit anyway. I might remove that and put it somewhere else and see if that removes that slight hum. You probably can't even make it out. It's very quiet. You probably can't even make it out on the lapel mic. There's a bit more hum than I'm comfortable with on the reverb return as well. All in all, everything's stable. Had it up and running for quite a while. Everything's pretty well locked in. Alright, so the reverb issue sorted. I moved the tank further away. I thought it was far away enough, but it was picking up quite a bit of hum from the power transformer, even though I had the pickup end way over here. So I've moved it way over on the other side of the bench. So that's master volume all the way up. That's the reverb maxed out. There was also a little bit more cleaning I had to do to the connector. I'd like to replace them with the right angle switchcrafts, but you're talking like, what are they, 20 bucks each? And then you've got 4 of them. The ones down here are fine, they cleaned up okay. So just retensioning and cleaning them has sorted it. But if there's any further issues in the future, I'll just let them know that I'll make up a new loom out of Canare cable, however you say it, with some switchcrafts on it, which is what I do for my own amps. So I'll give this a quick play and just see how it's reacting, and just that everything's nice and hunky-dory. I'll give it some power through the scope, pour a little scope in the dark there. And then if all's well, we'll get it back in the cabinet and do some sound samples. Alright, so I've reused the supplied switch. I've just put new switchcraft connectors on the end. I'm not a big fan of those, they cut through and stuff, but we'll see how the foot switch goes. Alright, so with the foot switch in and the reverb maxed out, we've got a fair bit of pumping coming from the tremolo there. But if you pull out the tremolo wire, it stops. So the pumping occurs where you've got the tremolo foot switch plugged in. You remove it, and obviously the tremolo stops. But you put in a blanking plug. Now that tremolo is actually operating, but there's no pumping. So that pedal is inducing a noise into the reverb return, which essentially this switch just shunts to ground when you turn off the tremolo. So could be the switch having a high resistance, it could be the wire, don't know. I'll try a replacement one I've got on the shelf, see if that's any better, and maybe just offer him that one. It's easier than trying to resurrect this thing. So I always keep one of these in stock. It's a Fender replacement for the vintage style plugs. Real good soldering they've done there. Left the flux on there, so I'll clean that off. It's always good to have some replacement common foot switches on hand, because people can just take them and go. You know, the usual Marshall style 2-button ones, the single button ones, and these in both the vintage style and the modern style, which has got the tip ring sleeve plug to suit the reissue amps. Alright champions, after hunting for that pumping problem, thinking I was onto something, it was just present on like all the power rails. It was present throughout the entire amplifier, almost like a modulated ripple hum. It was tracked it down to this little bastard. So I noticed when I was moving stuff around, there was sort of like microphonics being modulated by the tremolo, and yeah, pinned it down to this little asshole. JJ's fresh from eBay from the previous tech. This is why you don't trust eBay for tubes, because not only is it harder to return stuff, sometimes, you know, you got slightly unscrupulous sellers. So eBay sort of where all the trash ends up to get rid of once the primary vendors can't sell it or whatever. Alright champions, so I rearranged the wiring to go to the speed and intensity pot, just to try and dial out a bit more of that tick. There was a tiny bit there, so I did admit defeat and put a ceramic across the roach there, and now it's pretty much non-existent, so that's fantastic. That's what we're aiming for. Alright champions, slight complication. So there was a little bit of excess ripple on the screen node, so that's either caused by that 22 microfarad cap in the middle there not being up to spec, or our choke's playing up. So I'll substitute that cap with another one. Just eliminate that first, because that's the cheapest and easiest. And I'll substitute in a choke if I've got one floating around, if the cap doesn't get us anywhere. But we've got about 2.2 volts ripple on the screen node. It should be in the order of 200 millivolts or so. So there's quite a bit of 100 hertz hum in the output at all settings. So let's get to the bottom of that. There's always something, legends. There's always something to trip you up. Hey, we've got one floating around. Damn, I love how well stocked my shop is. Hang on a fucking minute. Where's the ground for that cap? So it's got no screen node filtering, but it sounds good. Holy shit. I guess it's because it's only got the 2.2K there, so this cap here is doing most of the work. I've totally fucked up here. Well, there you go. There's one for the record books. I think that's the first time I've ever made a mistake. No, just joking. I do it every day. Alright, let's establish a ground for that cap. This is a problem when you pull all the wiring out. You often, you might miss one or two, but not something as stupid as this usually, but, you know, never said I was smart. You know what? It struck me that that wire looked a little bit lonely in that hole, because there should be another one coming across here, and it previously grounded to the chassis right near the output valves. So I'll do that. Sorry, champions. I feel a bit embarrassed about this one, but, you know, just to show we're all human. So I had to get out the bloody chassis iron again, of course. We're just going to make the connection down there, right next to the cathode for that valve. I'll put a bit of blue tack, just a chunk that I've got for holding stuff where I want it to stay while I solder. If I'm tinning a bunch of wire, I'll just stick it to the chassis and stick the bit of wire to it. And it's good to have bits of blue tack lying around. I don't know if it's got a different trade name in the States, but goo for sticking posters on walls, that kind of thing. Making little cocks out of in high school and sticking them to your mate's back. Alright, there we go. Now let's fire it up and test how much ripple we've got on the screen node now. Place your bets. Alright, moment of truth. You know what? That big thump at turn-on's gone away now too, for obvious reasons. So we've got 446 DC. I'm sorry, I'm really embarrassed, champions. I shouldn't even be putting this up, but I want to be honest with you, alright? 446 DC on the screen node, and now, yeah, we've got about 200, under 200 milliamps ripple on the screen node in its quiescent state. So, a lot less hum now. That's great. Yeah, I feel really stupid now, so feel free to flame me in the comments. I deserve it. Give me a spanking. And the last of the tweaks, unlike the original schematic, I've moved the ground for the master volume to an actual ground instead of to the tail there with the negative feedback and whatever. And that has reduced the hum on 0 from the master volume to nothing. It is dead quiet now. So I don't know why they did that, but that's addressed that issue. Now I might just modify the end of this lead and make that ground lead a little bit longer so it's a bit less stressed. But this thing is ungodly quiet now with everything turned down. Let's max it out. No difference. I can't even hear a difference. Obviously you get a little bit of hiss there. Let's max everything out. Test for stability. Oh, a little bit of dirt there on the treble, but that's going away. Reverb, everything on full. Let's undo the tremolo for a minute. Picking up the camera. That's everything maxed out. And yeah, there's a bit of hiss, bit of hum, but we've also got the switch mode lighting above it as well. That helps. This is going to be a very quiet amp, so that's fan-bloody-tastic. Now, while we've got everything maxed out, just test it for a bit of microphonics. There's not a lot. There's some from the output valves. At the moment, it's drowned out by the noise. If I turn everything down again, there's no input on the reverb. That's why it was humming quite a bit. All right, so as Lyle says, now we're in a very good place. So, champions, what did we do? Well, it's more like, what didn't we do? Now, there's a bunch of people in the comments telling me I've gone way overboard. Okay, you put your name on this amplifier then and deal with any returns from future problems. I go well above and beyond what the average tech does because I want to have a good reputation. It's hard enough to keep a reputation as a tech with so many, shall we say, unscrupulous other poser techs out there, eroding trust that our potential customers have in us before they even step in the door. So part of the reason I started this channel was to show the process, keep it open and, you know, entertaining as well, but partially to set future customers' minds at ease that the job's getting done properly and thoroughly, which is so rare these days. There was also another contingent in the comments section saying that I hadn't done enough and I should have, you know, made a new board and made it out of like turret board and improved the layout and all of this. So how about you guys hook up with the guys that think I did too much and you just argue between yourselves and hopefully it cancels out in the wash, maybe? So obviously we did a recap and we replaced those drifted resistors. We cleaned the board and dried it multiple cycles with alcohol. We replaced all that wiring that had the green ooze coming out of it, which I'll go into shortly. Tightened all the hardware obviously on all the iron. Reused all but one of the Novel valves and tested and reused the 6L6s. They're a little bit rattly in the combo, which is a common thing with JJ's, but it's not coming through the speaker, it's just audible from the actual valve itself. Disconnected the main selector switch and locked it into 240 volts so that can't accidentally be changed, and the switch that's slowly destroying itself won't be a factor. Replaced the 4 output valves with new Beltons for various reasons. Check the previous videos for that where I go into detail. Replaced the cord and the strain relieving grommet. The nice heavy duty molded plug with the safety prongs there with the plastic on them. Prevents like a guitar string or something from falling in there and energizing. That'll wake you up. So just a quick look at the inside. We'll start from the input end. Again, as you saw in the previous one, the board was fully depopulated and cleaned. We shifted the layout a little bit, which I'll go over shortly. Redid the heater wiring. Did it my style with it down in the corner there out of the way. It makes servicing and whatever in the future a bit easier. Just keeps them out of the way and they don't end up melted like the previous ones were. I removed and soaked the original sockets in alcohol, cleaned them out, had all the wax there from the board that had eventually just coated the entire inside of the chassis. A lot of removing stuff was just to aid actually cleaning the chassis and all the wax off it. It's a lot easier to clean a flat piece of metal with some cutouts in it than try and navigate around a bunch of stuff that's installed in it. Replaced like 90% of the wiring because it all had that green crud coming out the end. Now that's actually, did a bit of research on it. They call it cable greening or something. Did research and I've already forgotten. My brain is so good. It's essentially the plastic breaks down and the plasticizer that's in the plastic compound comes out and starts attacking the copper. Someone mentioned that it's got PCBs in there, but I could find no evidence of that. When I say PCBs, I mean polychlorobiphenyls, which is very dangerous, carcinogenic and whatnot, but I couldn't find any evidence to back that up after a fair bit of research. Whatever compound it is wasn't actually conductive, but it was corrosive. So I removed all the wiring that had any sign of that and replaced it with some Carroll branded stuff, 600 volt rated. But then at the front end there, some of the other, I don't know if it was batches, but some of the wiring was fine, didn't have any sign of it. So clearly it was a batch issue. Apparently it's a big problem with house wiring in the States and UK as well. Yeah, not fun. Imagine, if you think this is bad, imagine having to rewire your whole house because it's got it. So we reused the blue caps. A very kind commenter seemed to take it upon themselves to instruct me on how to do the job, and they told me to not remove the blue caps. I'm well aware of that. The blue molded caps, I don't think I've ever seen one fail. So they all stayed in. Got some new V-shaped ceramics there for the treble control. We've got half-watt carbon films pretty much everywhere. We've got tube amp Doctor 105 degree rated bypass caps. We've got Panasonic film wherever I wanted to change the values or replace those ceramics, the disc ceramics there, for example, in the tremolo circuit where the legs have like cracked the ceramic body, so that's a path for moisture to possibly find its way in. Reused the Switchcraft connectors. They cleaned up okay with the brass wire brush. You can see here where I've done a bit of modification to the layout. Previously the bypass caps for the tremolo and the reverb recovery stage were mounted on those little tags down there under the RCAs. But I talked to the customer and they were happy to remove the boost. They actually preferred to go towards more of a straight up AB763 style circuit. So we got rid of the boost, got rid of the bright cap across the master, but we kept the master volume. And removing the boost circuit gave us a little bit of real estate there to reinstate like the traditional AB763 circuit in that area on the actual board instead of on the rear panel there. Previous Roach was dead. It was its neon was working, but the LDR, the minimum resistance, was still like 250k or something. So we've got a new one in there. We've got I dialed out the tick as well as I could with lead dress. There was still a tiny hint of it and it was pissing me off, so I did nip it in the bud and put a ceramic across the roach there, which got rid of the last of it. You can see here I kept the wires real tight for the tram, and most of that issue on most builds that I see from either cloners or older Fender stuff, it's usually excess wire in that area and just poor lead dress in that area that causes the issue. You can often just manipulate the leads a little bit or shorten them, and that sorts out most of it. Disconnected the humdinger pot there, heater balance pot. You can see the evidence of the arc damage there, which I only noticed upon editing the previous video. Someone took me to task in the comments again and asked, how do I know it was a flyback event? It's impossible to have a flyback event in this amplifier because it shorts to ground. Well, guess what? That contact down there, that fatigues, and that's why I've got a new socket in there too. But how do you know that someone didn't, plug it into a separate cab or disconnect the speakers for some reason and forget to plug them in? You can't say it's impossible to have a flyback event from no load condition. It's totally possible. I don't understand how you can just say it's impossible because blah. If you can plug a cord in, it's possible, right? I don't know how many musicians you know, but they're kind of like those aliens out of Fifth Element. If there's a red button, they'll push it. If you've got sockets, if you've got anything to tinker with, they'll tinker with it like crazy. So nothing is off the table when it comes to what happened to an amp. Who knows? I've had guys try to plug the speaker output into the input of another amp and blow the snot out of everything just because they were curious. So you really have to take that into account when you're dealing with musicians. They're artistic, creative, curious people, and there's no telling what they do behind closed doors. That sounds wrong. So anyway, we've got a new jack on there, and the other one was fine because it's just the backup one and it's got no shorting contact. We just gave that one a clean and it's a-okay. Reuse the switches. That one, I actually opened it up and had a look because I forgot that I thought they were rivets in the back. They're actually screws. You can unscrew them and clean them. Oddly enough, the stamping on this one, the little tooth that keeps the switch aligned was slightly off center. I tried to straighten them up, but the little anti-rotation tooth they stamp into the holes, you can see one there. See that little, oh come on Penny boy, see that little tooth there? That goes into a keyway sort of on the threaded bushing of the switches and prevents them from rotating, and that was slightly off center on those ones. I've never seen that before. Like the die wasn't aligned properly when they punched the chassis. That's why they're sitting on a little bit of an angle. No biggie. Can't tell from the back and it's not hurting anything. Rebuilt the bias supply there. I only used 2 diodes in series. Any more than that's an overkill. It just changes the potential across each one. Just lets them share the voltage across the 2 diodes and just makes them life a bit easier for them. The old ones had a very low voltage rating. I think they're only 200 volts or something, which is why they had 3 in series on each side, whereas these are 1000 volt rated. So you probably could get away with 1, but I put 2 in series anyway, and then just used a bit of bus wire to finish him off. Finish him! Metal film resistor in the bias supply there, new 105 degree rated Vichy electrolytic. Here's the new beauty sockets, Beltons. Had to enlarge the holes to get these in. There is a lip, you can see there just on the chassis. You can sit them up a bit. You've got to space them with like a couple of washers or something, and it doesn't look very elegant, so I just enlarged these holes in a quite dramatic drilling episode with the step drill. Original fuse holder was still good. Downrated the fuse a little bit, so it suits 240 volt mains. Previously it was sort of the worst case scenario for the voltage selector switch, which we've also disconnected now, partially because it's falling apart and partially because we want to prevent any accidental voltage selection here in Australia. We can just set it to 240 volts and forget about it. New grid stoppers. There's your new heater balance resistors. You see them there floating up the top. They're fusible, half watt, 100 ohms. In the event that you do have a short, they'll go open rather gracefully and you'll just notice a slight increase in hum. Maybe a little bit of buzz, but you won't set fire to the amp like if you had a grounded center tap on the heater winding on the power transformer. We've got new grid stoppers, and we've got new screen grid resistors there. Just went with a 2 watt metal film. All the wiring around here is redone. Sort of optimized as best I could. Some of the wiring, like the old transformer wiring there, I cleaned up with a bit of solvent and got all the soot and wax and crap off it, and it actually cleaned up pretty well. Re-established solder connections instead of using the transformer mounting hardware. Put a dedicated grounding point with the earth being the longest lead. So if you do somehow pull that cord out, which would be quite a feat, the ground pin will still be connected when the other two have exited the chassis. We've got our new bias, balance and overall bias level arrangement down here with that little trim pot adjusts the overall center point of the bias, and then the chassis mounted pot there still changes the balance between the two valves, so you should be able to optimize slightly mismatched valve sets, which is handy, especially these days. Got some flyback diodes there, so for whatever reason the secondary of the output transformer gets disconnected, goes open circuit, they will take the brunt of it and not allow the plates of those valves to attempt to reach infinity volts, which is what they'd try to do, divide by zero and whatnot. Now look at the front panel. I fully removed that brass plate and all the pots and the jacks and everything. I soaked the jacks. They actually still have tension in their contacts. I gave them a clean. All the pots cleaned up well. It's good. Didn't have to replace any of them. Switches too. There's the master there. I just reused the same pot. Could replace that with a standard pot. Now it doesn't require that tap or the switch on the back for the boost. Could have repurposed the boost switch for something else, but she's a twin, mate. I stuck a bit of fish paper under the pilot light there just to prevent it from possibly shorting out to the chassis. So in summary, it doesn't sound like that much work, but it's quite a bit. It's not really a amplifier that's optimized for quick reassembly. So all in all, after that summary, it doesn't sound like that much, but it was a complete rebuild. Very, very time consuming, but I wanted to get this one 100% right. So I think we're there. So let's get this back in the cabinet and we'll have a listen. Hey. Alright, champions, it's time to move on to the cabinet. So I'm going to, just to refresh your memory, fix up this wiring, hard solder it, get rid of these loose spade connectors, check the reverb cabling, possibly replace some connectors on there too. I'm going to check the reverb tank. I believe it measured okay, but I just want to make sure it's clean and everything's, hunky-dory. I'll remove this cover so we can access the cabinet and clean it with the vacuum as well. Maybe give it a wipe with a slightly damp sponge just to get the shmoo off. So the previous tech, when he removed parts, he's just thrown them in the cabinet. So they're just floating around. I think that one was sandwiched between the block and the back plate, and this was just rolling around. So that could have got caught in the speaker. The components with steel leads, could have got stuck to the magnet, but they're probably copper because they're not. It's just absolute carelessness. Quite hilarious. Not hilarious for the customer, however. Alright, so there's the cabinet droppings. It's one of the bias caps, a couple of screen grid resistors, and probably some bias resistors for the preamp, and the ceramic. Alright, champions, the cab's all cleaned up, rewired. Tank bag cleaned up beautifully as they always do. The tank's fine, it looks to be original, and it sounded good. And here's the soup we made out of the cabinet. It amazes me how much dirt comes off combo amps in particular, as well as the usual dirt and shmoo and spider webs and stuff that come out of it, dust. We'll give all that a good clean out. We'll tighten all the speaker hardware and make sure everything's snug.